My name is Rong Lu, and I am a program manager on the Visual Studio team. In this video, I'm going to show you how to use Visual Studio Code for C++ development. Here are the topics we're going to cover today. First, we'll talk about what Visual Studio Code is. Then we'll look at the Microsoft C++ extension, which enables VS Code to be a powerful development environment for C++. We'll then jump right into a demo to see everything in action. And I'll provide a few resources at the end. Visual Studio Code is a Microsoft product and aims to be a lightweight but powerful code editor. VS Code is completely free and open sourced and runs on multiple platforms, including Windows, Mac, and Linux. This code editor is highly customizable, so you can fully customize it to be your editor. VS Code provides built-in support for JavaScript, TypeScript, and Node.js, and many other languages, including C++, are supported via extensions. In this video, we're going to focus on the C++ extension. The Microsoft C++ extension for VS Code enables C++ IntelliSense, code browsing, code formatting, and debugging functionalities, making VS Code a very rich C++ development environment. We are very happy to see that it has been downloaded over 4 million times since it first shipped 18 months ago. Now let's switch to a demo to see everything in action. Here I have Visual Studio Code open on my MacBook. To find the C++ extension, you want to go over to the Extensions tab and search for C++ and find the one from Microsoft. And this is all we need for today's demo. Now let's go back to open the folder that contains C++ code. I'm going to open this project called Box2D, which is a physics engine that I downloaded from GitHub. I'm going to open that folder, and this has a number of CPP and header files in here. If I open any of these files, you'll see that out of the box we get C++ support right away, including colorization and hover over tooltips to give me some basic information. The out-of-box support is great and it's powered by a tag parser, but it doesn't have any semantic knowledge of your code. To get even better IntelliSense, you can help the IntelliSense engine by telling us what your include paths are, like suggested in the message box here. To configure include path, I want to go over to our configuration file by pressing Command-Shift-P and select Edit Configuration. Close this. And this opens a CCPP properties.json file where the include paths are defined. Now, by default, we generate a number of paths based on the OS that you're running on, and you can manually add any path here. But what I'm going to show you today in here is a feature that in our extension that helps you to find these symbols. For example, if I click on the green squiggle, I get a light bulb. If I click on the light bulb, I get a menu. And the first menu item that says Add to Include Path workspace root / box2d. Essentially, it's suggesting that, hey, you can potentially find this particular header file in this path. Oh, great. I can just click on that. And notice that the green squiggle just went away. If now we hover over some of these symbols, we actually get the exact type, no more ambiguity, and our IntelliSense is actually working. I can get multiple IntelliSense features in here. If I click on a symbol, we will highlight all the occurrences of this symbol in the current file. If I start typing, I will start getting member list popping up. And if I type my parameters are also hints for what the types are for my parameters. So this is all great help when you start writing C++ code. All these great IntelliSense features are going to make you more productive. Another scenario that our extension supports is code browsing. Sometimes you simply just want to browse in a large code base. You want to understand how the code works. and we provide support for you to go to definition or declaration. For example, we can say peek definition, which essentially brings in another CPP file where the definition lives in as an embedded window into my current file. So I can read the definition without having to leave my current file. So we talked a little bit about IntelliSense and code browsing features. And next, let's talk about building. So VS Code is targeting to be a lightweight editor, but it makes it possible such that you can bring in any external tasks into VS Code to build your code. Now let's go to this tasks.json file. This is where all the tasks are defined in VS Code. And it's pretty straightforward. You just have to pass in the command you want VS Code to invoke in here. Now in this particular case, I put my commands into a script file, which is also very straightforward. Now this particular project is set up to build with Xcode on Mac. Now I simply just navigate to the folder and then call the Xcode build command from here. Now if I go to tasks and run build task, VS Code is going to invoke these commands I defined here. And you can see I already successfully built my project from within VS Code. Now let's talk a little bit about how to set up the debugger in VS Code to debug your code. Now the C++ extension supports many different debuggers. On Mac, in here, I'm going to show you how to configure the LLDB debugger to debug your code. Now, to define the debugger experience, VS Code needs to know which program to launch. And this needs to be defined in a file called launch.json file. And here you'll see I have LLDB defined. And I just need to define where the program is and where my working directory is. And that's all I need to do in this JSON file. Now let's go back to my source code. In here, I have this function that says collide B2 collide circles, which means when two circles collide with each other, this function is going to be invoked. So let me just set a breakpoint here real quick, and then switch over to debug menu. Now I just have to launch the app by pressing the play button or press F5. This is going to launch my app with the debugger attached. Oh, great here. Let me get another circle in here and collides. Now my breakpoint is hit. In VS Code, we can step over my code right away. And as I do that, I can also watch the value of my local variables. If I spend here, as I step over my code, you can see the values changing. So it is really, really easy to set up the debugger in VS Code for C++. Okay, let me stop right here. So we walked through one program. We talk about edit, build, and debug. Now let's open another different program where I'm going to show you something we haven't talked about yet. Let me just close these files real quick. And to open another folder, I don't even have to leave the VS window, thanks to the latest multi-root workspaces support in VS Code. I just need to go to File, Add Folder to Workspace. I'm going to open another folder which contains C++ code I downloaded from GitHub as well. This one's called Bullet 3, which is another physics engine. In here, let's open another CPP file, something we already talked about, which is green squiggles along with a message saying that we could help the IntelliSense engine by configuring the include path for better IntelliSense results. Now, the reason I want to show you again is if we go to the edit the configuration file, you'll see, of course, you can manually add include path in here. But here's a question. For a project that's already set up to build, the build system, the build task should already have the knowledge of what headers to include in the build process. Can we use that for IntelliSense? And the answer is yes. The C++ extension now supports reading, includes and defines information directly from compilecommands.json file, which is a compilation database file consists of an array of command objects. Each object defines how a translation unit can be compiled in the project. And it can be generated by many build systems, including CMake and Ninja. In this case, I'm going to show you how to generate such a file using CMake, because this particular project is set up to build with CMake already. And this is done in the script file, where it says CMake and passing a bunch of flags. And this is the normal build process. So to generate a compilecommands.json file, it's really easy. All we have to do is to pass in this flag to CMake. We'll add it here. And that says I want to export a compilecommands.json file. And that's all I need to do. And at this point, I basically just have to rerun the script. And that is going to generate this file in my build directory. Since this is going to take a couple minutes, I'm just going to show the one I generated earlier. And in here, you see each source file is in one of these objects. And the command is defined here for what compiler to use and what includes need to be passed in there and a bunch of other information. Now, the only thing we need to do here is to go back to my configuration file. And instead of using include path property, I'm going to use a different property named compile commands. And I just need to pass in the path to this compilecommands.json file in here. And I'm going to do that here. Copy it over and save this file. Now let's go back to our source file. Just like that, all the green squiggles went away, and I can start enjoying the full IntelliSense experience without me having to manually configure any of these settings. And this is pretty awesome. And this wraps up the demo today. In the demo, I just showed you how to use VS Code along with the C++ extension to edit, build, and debug C++ programs, how to use the libel suggestions and leverage the compilecommands.json file to quickly get rich IntelliSense ready to assist with editing, how you can integrate external tasks into your workflow in VS Code, and how you can easily set up the LLDB debugger to debug C++ programs on Mac in VS Code. Hope you all like it. Here are a few resources. You can download VS Code from here and download C++ extension from here, and a few links to our docs, how to provide us feedback, and where to log issues and suggestions. Finally, follow us on the VC Team blog and our Twitter account at VisualC to get the latest news on VS Code for C++. Thank you.